Welcome to the third video in Section 5. In the previous video, we introduced the Akka cluster and implemented a cluster system. In this video, we will take a look at cluster metrics. Then in Introduction to Routers, we'll introduce the load balancer, adding routers, and finally, add it to our cluster. Let's begin. In our example from the previous video, we have one front-end node and three back-end nodes. A front-end node has a list of backends, and for every operation it selects, a random backend to handle it. Our front-end uses a random selection strategy for the group of backends connected to it, which is similar to the behavior of a router. As we know, Akka has multiple routing strategies implemented already, like the random or the round-robin strategy. It's also possible to implement a custom strategy. On top of that, there is the cluster metrics extension, which has an adaptive load balancing strategy that will select nodes based on the cluster metrics data. But what's cluster metrics and cluster metrics data? Cluster metrics report the system's health status back to Akka, and it can base its routing decisions on it. Every member node in the cluster collects data about system health, such as its used and max JVM heap memory, system load average for the past minute, CPU utilization. This data is used by adaptive load balancing to perform load balancing of messages to the cluster nodes. It uses the random selection of routees with probabilities derived from the remaining capacity of the corresponding node. Now, let's add a load balancer to our example. First, let's add the configuration for our router, which is similar to other routers but with additional configurations. We will define something known as the metrics selector, where we will use a mix technique that works based on heap load and CPU data. We will define the cluster configuration. For this, enable a cluster, disable local routees, and specify the node role that will contain routes. That is our front end, which is similar to the previous front end, but doesn't have a back-end list. Let's create one here, a scheduled task which sends a message every 3 seconds. Now, the front end appears to be like the one seen in the previous videos. Let's create the back-end router now. The back-end is a simple actor, which handles one message. This back-end object is similar to the back-end seen in the previous videos. In the app object, we start 3 back-end nodes and a front-end node. Let's run our app now. Yeah, it's working. Beautiful. At the end of this video, we added a router to our cluster to route between back-end nodes. See you in the next video, where we will introduce and implement the cluster singleton.